Picture this. It's early 1963 at Riverside International Raceway in California. Carroll Shelby, the legendary racer turned manufacturer, stands trackside watching his creation, the brand new Shelby Cobra 289, tear around the circuit. The car is a work of art. Sleek British roadster body wrapped around American Ford V8 muscle. 271 horsepower, 0 to 60 in 5.9 seconds, capable of embarrassing Corvettes and giving Ferraris a run for their money. Shelby is beaming. This is the car that's going to make his reputation as a manufacturer. Then something impossible happens. A beat-up 1957 Chevrolet Bel Air rolls into the paddock. Not a race car, just a street-driven two-door hardtop that looks like it's seen better days. Faded white paint, stock steel wheels. The whole car sitting about 3 inches too high on worn suspension. Someone's grandma car. A few drivers chuckle. The Cobra crew smirks. What's this? Old fat brick doing at a racetrack? The Chevy driver, a mechanic named Ray Nichols from Illinois, overhears the comments. He doesn't say a word, just pops the hood. Underneath sits something that makes Shelby stop mid-conversation. A Chevrolet 283 cubic inch V8 with Rochester Ramjet fuel injection. The distinctive intake manifold with 8 individual injector nozzles, 1 per cylinder, gleaming in the California sun. Shelby knows exactly what he's looking at. This isn't some grandmother's grocery getter. This is the car that changed everything in 1957. The car that dominated NASCAR so completely they banned its fuel injection system. The car that achieved 1 horsepower per cubic inch before anyone else. The car that, despite being 6 years old and looking like a family sedan, could still run with the best performance machines America had to offer. Nichols catches Shelby's eye and grins. Want to run for pinks? This is the story of how a seemingly obsolete 1957 Chevrolet Bel Air with revolutionary technology made Carroll Shelby's cutting-edge Cobra look ordinary. How General Motors created a fuel injection system so advanced it wouldn't be matched for decades. And why an old fat brick from the Eisenhower era became one of the most dangerous sleepers in automotive history. To understand why Shelby should have been worried, we need to travel back to 1956. Chevrolet had just launched its small block V8 in 1955 to massive success. The 265 cubic inch overhead valve design was lighter, more powerful, and more efficient than anything Ford or Chrysler offered. But Chevrolet engineer Zora Arkus Duntov, the Belgian-born genius behind the Corvette's performance development, wasn't satisfied. He had a vision: create an engine that produced 1 horsepower for every cubic inch of displacement. In 1956, that was considered impossible for a production car. Sure, race engines could do it with alcohol fuel and constant rebuilds, but a street engine that could idle smoothly, run on pump gas, and last 50,000 miles while making 1 horsepower per cube? Every engineer said it couldn't be done. Duntov disagreed. The problem with carburetors, even the best 4-barrel designs, was fuel distribution. You had 1 or 2 carburetors trying to feed 8 cylinders through a shared intake manifold. Some cylinders ran rich, others lean. At high RPM, fuel would puddle in the manifold instead of flowing smoothly. You lost power to distribution issues, not engine limitations. The solution was obvious. Put a fuel injector at each cylinder's intake port. Meter fuel precisely based on airflow. Eliminate distribution problems entirely. Simple concept. Extraordinarily difficult execution. Chevrolet partnered with Rochester Products Division, GM's carburetor manufacturer, to develop a mechanical fuel injection system. Not electronic, 56, and transistors were still exotic laboratory equipment. Everything had to be done mechanically, using vacuum signals, diaphragms, and precision machining. The Rochester Ramjet, as it became known, was a masterpiece of mechanical engineering. At its heart sat the fuel meter, a complex assembly of springs, diaphragms, and plungers that measured engine airflow and delivered precisely the right amount of fuel. A venturi in the air intake created a vacuum signal proportional to airflow. A large diaphragm measured this venturi vacuum. Simultaneously, a smaller enrichment diaphragm measured intake manifold vacuum. These 2 signals worked in opposition. The venturi vacuum tried to open a spill valve that controlled fuel delivery. Manifold vacuum tried to close it. The balance between these forces determined exactly how much fuel reached the injectors. Under cruise conditions with high manifold vacuum and moderate airflow, the enrichment diaphragm dominated. Fuel delivery stayed lean, for economy. At wide open throttle, manifold vacuum dropped to near zero while venturi vacuum peaked. The main diaphragm took over, flooding the injectors with fuel for maximum power. The system automatically adjusted for every possible combination of throttle position, engine speed, and load. A gear pump driven off the distributor supplied fuel at pressures ranging from 7.2 psi at idle to over 530 psi at 6,000 RPM. Think about that. 530 pounds per square inch of fuel pressure generated mechanically in 1957. Modern electronic fuel injection systems typically run 43 to 60 psi. The Rochester system ran nearly 10 times higher pressure, all controlled by vacuum signals and mechanical linkages. 8 fuel lines carried this high-pressure fuel from a central manifold to individual injectors. Each injector was a simple nozzle with no moving parts. Fuel sprayed continuously into the intake port, not pulsed like modern electronic injectors. This meant fuel was always being delivered, the amount varying with fuel pressure. At idle, low pressure meant a fine mist. At full throttle, high pressure created a dense fog of atomized gasoline. The system required insane precision. The venturi had to be machined to exact dimensions, or the vacuum signal would be wrong. The diaphragms needed perfect flexibility, or they'd stick. The spill plunger had to move freely through its bore with clearances measured in 10,000ths of an inch. Any contamination in the fuel would jam the system. Getting it to work required Rochester's best engineers and machinists spending 2 years refining every component. But when they got it right, the results were staggering. Chevrolet bored the small block out from 265 cubic inches to 283. With Rochester Ramjet fuel injection, a hot cam, and higher compression, the engine produced 283 horsepower at 6,000s. 200 RPM, 1 horsepower per cubic inch. Nobody had done that before in a production car. Chrysler's 300B from 1956 made 355 horsepower from 354 cubic inches, beating the 1-to-1 ratio. But that was with dual 4-barrel carburetors, and it couldn't match the Ramjet's drivability. The fuel-injected 283, which hot rodders called the fuelie, could idle at 900 RPM smooth as glass, then scream to 7,000 RPM without hesitation. Throttle response was instantaneous. Stab the gas and the engine responded with zero lag, no carburetor bog, no flat spots. Road and Track magazine tested a 1957 Corvette with the fuelie engine and clocked 0 to 60 in 5.7 seconds. The quarter mile took 14.3 seconds. For 1957, those numbers were science fiction. A Mercedes 300 SL, the exotic German sports car costing 3 times as much, needed 7.4 seconds to reach 60. The fuel-injected Corvette was almost 2 full seconds faster. Top speed was limited only by gearing. With the right final drive ratio, the fuelie could exceed 150 miles per hour. But Chevrolet didn't just put this revolutionary engine in the Corvette. For one glorious year, you could order Rochester Ramjet fuel injection on any Chevrolet passenger car. Want it in a Bel Air sedan? Absolutely. How about a 152-door Post, the cheapest, most basic Chevrolet you could buy? No problem. Order code number 579-D for 250 horsepower fuelie, or 579-E for the full tilt 283 horsepower version. Cost was $484.50, about the same as air conditioning. This created the ultimate sleeper. Imagine pulling up to a drag strip in 1957 in what looked like a taxi cab. Plain Jane Chevrolet 150, 2-door sedan, poverty caps on the wheels, bench seats, rubber floor mats. The muscle car guys with their Chrysler 300s and Oldsmobile Rocket 88s would laugh. Then the tree would go green, and that invisible fuelie engine would launch the lightweight Chevy like it was shot from a cannon. By the time they realized what happened, you'd be crossing the finish line. General Motors noticed the racing potential. In late 1956, despite an official company policy against racing following the Le Mans disaster of 1955, GM secretly established the Southern Engineering Development Company, SEDCO for short. This shadow operation existed to support NASCAR and drag racing without GM's name attached. SEDCO published the 1957 Chevrolet Stock Car Competition Guide, a detailed manual explaining how to turn a base model 150 into a NASCAR race car. The recommended package was brutally simple: 152-door sedan for minimum weight. Delete the rear seat to save more pounds. Delete sound deadening. Delete the heater. Install heavy-duty suspension components. Fit the 283-horsepower fuelie engine. Add a 4-speed manual transmission. Paint it black and white. The result became known as the Black Widow, and it dominated NASCAR in 1957. Drivers Buck Baker, Speedy Thompson, and Jack Smith piloted Black Widows to 16 victories in the Manufacturers' Championship. The cars were nearly unbeatable on short tracks where their lightweight, superior handling from the small block's forward weight distribution, and relentless high RPM power gave them massive advantages over heavier, lazier big block competitors. NASCAR panicked. By mid-season 1957, they banned fuel injection. Too exotic, they claimed. Too expensive. Too much of an unfair advantage. The real reason was simpler. Chevrolet was making Ford and Chrysler look like amateurs, and NASCAR needed close competition for fan interest. Even with the fuel injection ban, the Black Widows kept winning on carburation alone, proving the 1957 Chevy's basic superiority. But let's get back to 1963 and that meeting between Ray Nichels' fuelie Bel Air and Carroll Shelby's Cobra. Nichels wasn't bluffing about his 6-year-old Chevy's capabilities. He'd been maintaining and racing fuelie cars since 1957. He understood the Rochester system better than most engineers who designed it. His Bel Air looked stock and rough, but underneath was a carefully developed street strip weapon. The engine was internally stock 283 cubic inches, stock forged crank, stock connecting rods, stock block. But the fuel injection had been meticulously tuned. Nichels had spent hundreds of hours on a flow bench optimizing the Venturi dimensions. He'd modified the diaphragms with stiffer springs for better high RPM response. The injector nozzles had been enlarged slightly for more fuel flow. Most importantly, he'd replaced the stock camshaft with a more aggressive grind. Valve lift increased from 350 thousandths to 462 thousandths. Duration stretched from 248 degrees to 278. The overlap period, where both intake and exhaust valves were open, simultaneously created that characteristic lumpy idle and tremendous high RPM breathing. With these modifications and careful tuning, Nichels' fuelie made 325 horsepower at 6,500 RPM, more than the Cobra's 271. But power was only part of the story. The Bel Air weighed 3,400 pounds compared to the Cobra's 2,100. That 700-pound disadvantage should have made the race a runaway for Shelby's car. Should have. Nichels understood something that many racers missed. Traction was everything. The Cobra made glorious power, but putting it to the ground through skinny bias ply tires on a short 90-inch wheelbase was nearly impossible. Floor the throttle and the Cobra would spin its tires through second gear, going sideways instead of forward. The Bel Air, on the other hand, weighed enough to plant its rear tires. The longer 115-inch wheelbase provided stability. Nichels had installed traction bars to prevent axle wrap and fitted the widest tires that would fit in the stock wheel wells. The result was a car that could actually use its power. The impromptu race happened on a deserted stretch of California highway. Not smart, not legal. But this was 1963, and nobody cared much about street racing. Shelby drove the Cobra himself. He wasn't going to let anyone else risk his reputation. They lined up side by side, Nichels in the ancient Bel Air, Shelby in the gorgeous Cobra. Someone dropped a handkerchief. Both cars launched. The Cobra's exhaust note was a furious scream, all high RPM intensity. The Bel Air produced a deeper, more mechanical sound, the fuel injection creating a distinctive whistle as air rushed through the Venturi. For the first 100 feet, they were dead even. Then the Cobra's rear tires broke loose. Shelby caught the slide, feathered the throttle, trying to find traction. Nichels just kept his foot planted. The Bel Air hooked up and pulled away. By 60 miles per hour, the Chevy was half a car length ahead. At 80, a full car length. Nichels shifted to third gear at 6,500 RPM. The fuelie engine never hesitated, just kept pulling like a freight train. The Cobra finally found traction and started clawing back. Shelby was a world-class driver, and he extracted every bit of performance the car had. At 100 miles per hour, the gap started closing. The Cobra's superior aerodynamics and power-to-weight ratio began to matter. But it was too late. Nichels crossed their predetermined finish point at 110 miles per hour, still half a length ahead. Shelby pulled alongside and gave Nichols a thumbs up. No hard feelings. The Cobra was the future of American performance, lightweight roadsters with massive engines. But that old fat brick from 1957 had just taught everyone an important lesson. Advanced technology beats raw displacement. Proper setup beats theoretical advantages. And never, ever underestimate a fuelie. The encounter became legendary in Southern California racing circles. Shelby supposedly told his engineers, "Figure out what makes that Chevy so responsive and put it in our cars." The result was Shelby's focus on tuned fuel delivery and instantaneous throttle response that became hallmarks of his performance philosophy. But the 1957 Fuelie's influence went far beyond one street race. The Rochester Ramjet proved that fuel injection could work on production cars. It demonstrated that mechanical systems could achieve precision matching electronic controls that wouldn't exist for another 20 years. Most importantly, it shattered the myth that more displacement was the only path to more power. The Fuelie made 1.14 horsepower per cubic inch in street tune. Race versions with higher compression and wilder cams exceeded 1.4 horsepower per cubic inch. Modern naturally aspirated engines struggled to beat those numbers. A current Corvette Z06 makes 460 horsepower from 6.2 liters, about 378 cubic inches. That's 1.22 horsepower per cube. The 1957 Fuelie was within striking distance of that 68 years later. The technology eventually died, not because it didn't work, but because it worked too well. The Rochester Ramjet required precision manufacturing and expert tuning. Most mechanics didn't understand it. Owners who didn't maintain the system properly experienced problems. Dirt in the fuel would jam the spill plunger. Incorrect idle adjustments would cause stalling. The high-pressure fuel pump would fail if the fuel filter wasn't changed regularly. Chevrolet got flooded with warranty claims from owners who treated the Fuelie like a regular carburetor engine. By 1965, Rochester Ramjet fuel injection was discontinued. Chevrolet went back to carburetors and wouldn't offer fuel injection again until 1982, when electronic systems finally became reliable. But those 8 years of production, 1957 through 1965, created legends. Fuel-injected Corvettes set race records and established the car's reputation as a legitimate sports machine. Fuelie passenger cars became the ultimate sleepers, looking ordinary while packing exotic technology under the hood. Today, a documented original Fuelie car commands huge premiums. A 1957 Chevrolet 150 Black Widow in race trim sold at auction in 2023 for $1.2 million. With the 283 horsepower Fuelie can bring $250,000 or more. The system itself has become a cottage industry. Specialty shops rebuild and restore Rochester Ramjet units, charging $5,000 to $8,000 for a complete overhaul. New old stock parts command astronomical prices. An original Venturi casting can cost $1,200. A fuel distribution manifold runs $2,000. Collectors pay these prices because the Fuelie represents a unique moment in automotive history. The period when American manufacturers were willing to experiment with advanced technology just to see if it could be done. When engineers like Zora Arkus Duntov could convince bean counters to spend millions developing systems that would only sell in small numbers. When cars were defined by innovation rather than quarterly profits. The 1957 Bel Air Fuelie also proved that revolutionary technology doesn't always come in revolutionary packaging. It looked like every other Bel Air on the road. Same tail fins, same chrome trim, same basic silhouette. Only that distinctive fuel injection intake manifold under the hood gave it away. This made it the ultimate Q-ship, a military term for armed merchant vessels disguised as harmless cargo carriers. The Fuelie Bel Air was Detroit's Q-ship, looking like transportation while packing exotic weapons-grade technology. Carroll Shelby understood this better than most. His Cobra was revolutionary precisely because it combined advanced lightweight construction with proven powerful engines. But that encounter with Nichols Bel Air taught him that packaging mattered less than execution. You could have the prettiest, most advanced-looking car in the world. If someone else had better technology and knew how to use it, your pretty car was going home with a loss. The lesson stuck with Shelby throughout his career. When Ford came to him with the GT40 program, he insisted on mechanical fuel injection for reliability. When he developed the Mustang GT350, He focused on making existing engines more responsive rather than just bigger. Every Shelby creation emphasized drivability and instant throttle response, characteristics the 1957 fuelie demonstrated so convincingly. But perhaps the greatest legacy of the fuelie Bel Air is philosophical. It proved that the establishment could be wrong. In 1956, every expert knew that 1 horsepower per cubic inch was impossible in a production engine. Zora Arkus Duntov and his team at Rochester Products proved them wrong. Every expert knew that fuel injection was too complex for street cars. The Ramjet system proved them wrong. Every expert knew that a 6-year-old family sedan couldn't compete with cutting-edge sports cars. Ray Nichols proved them wrong. The engineers who created the Rochester Ramjet didn't accept conventional wisdom. They asked why. Fuel injection couldn't work on production cars, and then solved every problem standing in the way. The result changed automotive engineering forever. Today's cars with computer-controlled port fuel injection or direct injection are direct descendants of that 1957 mechanical marvel. Every time a modern engine produces 100 horsepower per liter, about 1.6 horsepower per cubic inch, it's walking a path the fuelie carved out decades earlier. Every time instant throttle response delights a driver, that's the legacy of engineers who refuse to accept carburetor lag as inevitable. Every time a sleeper sedan surprises a sports car, that's the spirit of the 1957 Bel Air living on. So what can we learn from the old fat brick that made Carroll Shelby's Cobra look ordinary? First, that packaging doesn't determine capability. Advanced technology can live in the most unexpected places. Second, that execution beats theory every time. The Cobra should have won that race on paper. In reality, proper setup and driver skill mattered more. Third, that innovation requires courage. Chevrolet spent millions developing fuel injection knowing it might fail. They did it anyway because the potential rewards justified the risk. Fourth, that legacy isn't measured in sales figures. Rochester Ramjet fuel injection never sold in huge numbers. Most 57 Chevys had carburetors. But those few thousand fuelie cars changed the industry forever, proving what was possible and inspiring generations of engineers. The next time you see a 1957 Chevrolet Bel Air at a car show, look under the hood. If you see that distinctive Rochester Ramjet intake manifold with 8 individual fuel lines, you're looking at automotive history. The car that achieved 1 horsepower per cubic inch first. The car that dominated NASCAR so completely they banned its technology. The car that made Carroll Shelby rethink his assumptions about what mattered in performance. The old fat brick that was never fat at all. Just ahead of its time, underestimated, and more dangerous than anything else on the road. That's not just engineering. That's revolution wrapped in chrome and tail fins, waiting to embarrass anyone foolish enough to think old means slow.